Okay, I'm going to end the poll now. We have some interesting results already and get on to the panel discussion. Ferdinand, at the end of your presentation, you discussed about, the speed to adopt these new tools. And I guess a question is it riskier to adopt what's available now and train your engineers on AI, which seems like it's shifting sand in many ways and things are moving so quickly? Or would it be better to wait until things have matured more and then decide how to act? What do you think at this stage, what are you seeing happening in industry?
Yes, so you have to start now because the technology will the change technology will so fast because we are in AI is not at the end in its development. So if you not start to train your organization to use AI now, to transform your organization now, your process now, you won't do it anymore, and yeah you won't be competitive anymore. So start now, go for it now, and then go by the new technology, and don't stop. Go further and further.
Yeah, we're seeing that at the CDFAM events organized where it's not so much about the tools available today, but the mindset of those who approach it. And I think there was a pretty interesting meme about Rick Rubin sort of talking about how like it's really not about any of the tools, it's about how we start to utilize them and then as quickly as we can get them adopt them. Maurice, what are you seeing from your customer base in the reaction to the agentic systems and how they can sort of adopt, how quickly they can adopt these and what the risk is for taking their time?
I was recently talking to Ryan from NASA. I guess you know him as well, at one, and he had a very good picture for me, and I totally can see this also at our customers. He said, "Well, at the moment, there's two type of persons. There is the persons who have been taking the AI pill, so they are evangelizing, they're pushing forward, they always see the upside potential." And then there's the more, let's say, realistic or conservative people who are, oh, don't touch it. Maybe this will even replace me in the job offer. So it's really something which is separate. I don't see many people who are in the middle. So it's either you give it a chance and you go for it, or you are pushbacking. And I think this is kind of like normal for humans, but also kind of like what I think when now a customer, for example, of us wants to evaluate, and I guess Ferdinand said it, it's about the mindset of people. So you need to find this group of people who are open to this technology for the first pilots to build trust, because this is mandatory. If you don't have built trust with the real data, with the real workflow, in PowerPoint everything looks kind of fancy, but really on the engineering level, where you need to like trust the crash results or crush the thermal mechanical stuff, you need to prove it. And I guess that needs to be done by people who are motivated, who are open-minded for this new technology.
Yeah, often you see those people in the R&D divisions. How do you see that sort of spreading out into the engineering guys who are more risk adverse?
Yeah, I think it has some similarities with all of the new technologies, similar to additive manufacturing at the beginning. You also see these people. I also see kind of like a trend that it's, of course, not black and white, but I see a tendency to have younger people adopting this technology easier. So, because they are like, nobody has been an expert, has been able to train this or study this. So everybody starts from scratch. So if you are an expert working, I don't know, 20 years in CATIA maybe, it's very risky for you to actually get like a new joiner coming into the company with an AI tool doing, maybe it's not working, but it promises to work text to CAD. You get like really like a problem. So yeah, it has similarities, and definitely the more open-minded, the more R&D-ish you are, the also more, maybe the more T-shaped you are. So not an expert in one field, maybe more towards Python scripting and CAD and simulation, exploring cloud software tools. Like all of these, let's say, patterns kind of make a good person or candidate for trying out these new software tools.
Yeah, interesting. So, Stephen, I was at ICAM last week, which is ASTM's conference on advanced manufacturing, and they were saying this similar sort of pattern with the bottom up, sort of bringing new technologies into the engineering workflows, and the leaders pushing down, saying, we need this now, work on this. And it was the middle management and those who have been in their roles for 20 years who are more hesitant to adopt these tools. Is that something you're seeing as well with your client base? And how can we sort of convince them to step into 2025?
Yeah, exactly. It can be that way. And I would agree with Moritz that different people are quite polarized at the moment. And we've been seeing this for quite a while now because being a completely cloud native solution, we've been fighting that battle for quite a long time where you'll speak to a simulation leader and they're either completely on board with having a unified tool that runs in the cloud, doesn't require local hardware, or they're completely against it. And we're seeing something similar with AI. I would say it's similar where the younger engineers, it's not always the case, but are often more open to adopting new technologies. The other thing that I think has happened, unfortunately, is we're in the era of the failed AI POC. Many organizations have tried something and they may have burnt their fingers and had a bad experience. And that makes them a bit more hesitant to invest heavily again without actually working out how to deploy that solution broadly and correctly once the pilot has been completed.
Yeah. Blake, I think you shared the quarter hype life cycle in your chart at the end. How you've been at the bleeding edge of many of these adoptions of new technologies in the past, and sort of abstracting it from not being about AI and ML, but just adopting new technology to begin with. Maybe the software is exciting to use, but how do we sort of get middle management to see the value of this?
Yeah. I mean, from the other side, when you're trying to bring new engineering technology to the world, it's a difficult match to make. And I mean, this in startup land, I guess we call this go to market, and I'd say that focusing on value is always the most important thing. I think we try to not worry about as much about individual productivity as the opportunities that are unlocked by a new wave of technology. So, for example, with Space Claim, we just made it easier to use solid modeling. You didn't need as much CAD training and also not as much sort of respect for CAD standards to do things. And we found that manufacturing engineers and simulation engineers and 3D printing people and concept engineers and all these people could reuse all this CAD asset and do new stuff with it without getting in the way. But it looked just like a CAD system. And SketchUp had been around successfully saying SketchUp's not CAD. But like in architects, I think could understand that, but engineers, mechanical engineers are a little too literal. And so it created a lot of dissonance. And our biggest customers, and we're talking about automotive companies and tier one suppliers and big names, we were like learning they would have like a lean product development initiative. They have a Kaizen event and bring in Space Claim. And it was really interesting to see that they were using us to innovate and remove friction in their process, not because they wanted to make geometry. And we were making CAD systems because we like geometry. And so understanding that there's some other business process value at stake, and that's what you're really doing, I think is the key. And that's why when I think I look at these kind of new technologies, and I think as engineers, we always like look at new technologies with skepticism and try to figure out how it's going to break. I think the answer is to say, hey, look, there is friction. We know where it is, and any reasonable person can identify a problem and start to solve it. And I think it's that moment of talking to of find leaders in enterprises who are willing to say, hey, if we make this little bit of a process change, if I break this IT rule or whatever it is, it might unlock some value. Having a culture where you can measure that and demonstrate a result. And if you can demonstrate to your peers that you've unlocked something and added some value, then the company can invest in it. And if you're at a company where you can't do that, well, I would go crazy. So
I see I'm muted. Yeah. So yeah, the data is the issue of data is not only in the design, manufacturing, and performance data of the parts we're making, but how we come about them and how we can help ourselves be more efficient in the design engineering process, not just the results of the manufacturing process yourself. Ferdinand, do you see something similar? And maybe the adoption is easier to sell when it's calling augmented existing engineering workflows rather than replacing processes and people?
I guess replacing people shouldn't be your target. It's not about replacing people.
Of course, yes.
And if you communicate it in the right way and you communicate your goal, your target, and it's more like, yeah, we want to help you because your mindless, repetitive processes, nobody wants to do that. Everybody wants to have time for the nice jobs, for the nice activities. So if you tell them, we can help you to automate your not motivating tasks to have more time for the others. That's the way how to talk to engineers, because every engineer want to be creative, want to be innovative, and that's the way how to motivate them, how to talk to the people, and then I'm convinced that it will work. And it's not about replacing people.
Of course, yeah. How I think that's a fear that some people have. So we all know that we're not replacing anybody, we're just helping them to do their job better. Once you find that person who understands that within an organization, what do you provide to them to help them convince their colleagues, apart from success, that this is the way to approach that? These AI agents are there to help them, not to take away their jobs. And
Steve Jobs said that when he invented the personal computer, his inspiration was the bicycle. He said that a bicycle purportedly makes someone like 80 times more efficient at propelling themselves forward than walking. And what he wanted to build was a bicycle for the human mind. And I think that when you think about automation and abstraction, it's very easy to have this Charlie Chaplin-esque image of like the machine just moving faster and everyone going crazy. But I think the vision and the thing to look for is that feeling of riding a bicycle when you're just sort of gliding along effortlessly, where before you were having to do real work.
Yeah, I think the convincing thing for middle management is to really understand that they can do more with the same team that they've got. Like, not talking about letting people go, replacing the staff that they have, but exactly what Ferdinand was saying and what Blake was saying, it's about being able to do those tasks more easily, removing that repetitive, boring job from the process and allowing the engineers to concentrate more on the bigger picture, the overall intent of the design that they want to create.
Yeah, I'm sure most engineers have had enough time of clicking edges and filling out Excel spreadsheets. So
there's another opportunity, which is, as an engineer, if you can ever say, we can use this and increase our revenue. Now, not just like we can go home at 5 o'clock instead of 6 o'clock, but we will enter a new market. Like, hey, we've been making products like this for 10 years and we have all this historic data, but we have an SKU for everyone. Could we use that data to come up with a quoting tool for a purely customized version, right? Like now you can make a web configurator and we can put leads right there as a top of funnel experience. There's all this stuff that you can do to reuse engineering knowledge to make a better business.
Well, just recently had an example where a customer came to us and said, well, we are like have been electrical bicycle manufacturer. And they said, well, we are getting the parts back from the field with some testing data in day X. And then we need to know what kind of simulations we need to adopt and what need to have design changes we need to adopt to improve the quality of the product within 2 weeks. And there's actually no way we can do this, because actually like bringing in the CAD, doing the simulations, doing all of the material modeling, and then doing the reporting, and then going back to CAD, changing the design, this will take forever and not like the time that we have. So I guess there are use cases out there that are just not solvable without these kind of automations where actually it should make sense to go.
Yeah. Maurice, we see in architecture where when they're building computational workflows, it may take longer to build up this system to solve the problem rather than just solving the problem.
Mm-hmm.
Once you have these modules, you can reuse them again and again and again. How do you help your engineers and their managers understand that investment in building that system is of much greater value than solving the immediate problem that they have today?
I usually try to say, well, what we are doing actually is we are not designing the part we are more modeling the workflow or the process that then automatically designs the part. So I guess we are one level in abstraction higher. We're creating automated rules, and these rules could be applied on different types of parts. So think about a crash simulation. This is not really depending on the geometry on the part. If you set up the rules properly, you can throw into the process multiple parts. So it could be the case that you design one workflow which can simulate the A pillar, the B pillar, and the C pillar of your car in the same way. And this kind of makes it recyclable. And at the end of the day, it's always a business case. So I guess it's lots of discoveries that you need to make. You need to look into your process maps and think, okay, this process, for example, number one, is it on the critical path of more product development? So if I speed this thing up, will it have a direct impact on my go-to-market or any kind of the KPIs which I'm interested in? Second is this process repeatedly done? So is it worth the investment one time? Because actually I have 10,000 of these parts and processes down the line, which I can apply this to. And I think then at the end, there are use cases which doesn't make any sense to automate because they are kind of one-off processes, or they are not, it's way too much effort to invest in automation. And there are processes who are like pretty amazing. Just one automotive customer, aerospace customer from a big aerospace company. And he said, well, he automated a process and now it's 99.8% faster. That's crazy.
That's considerable. I guess when you're talking about putting in systems and then using it for a different application, like we know that AI machine learning is better for interpolating between different results. How do you go and expand out and explore beyond those given domains?
I would say it depends a little bit on the use case. So let's take the very obvious one, reduced order models, where you predict the simulation results. They have been done in the past. They're basically only interpolations. So the moment that you actually like want to predict the simulation, which has been not part of the training data room, I would not trust the results that much, right? So you need to interpolate basically in the middle. But if you think about use cases, for example, where you use the Gen AI topic, like an LLM, which has been pre-trained on basically the internet knowledge, you can pretty much rely on the expertise which is out there in the internet. So all the rules of engineers and stuff, or all the GitHub files. So there's basically so much knowledge that even if it's not inventing something new, it feels new for you because it's just combining data points out of such a big data set that you can think about it in a limited space as creative tasks. Obviously it's not, but it's so complex combination logics that it feels kind of like creativity.
We've seen limitations of LLMs and VLMs for geometry and their spatial awareness as being kind of a limiter for now. I'm sure that over time that will advance given the right data. But I guess a question to you, Blake, is how can we move forward if LLMs and VLMs don't really have spatial awareness, and synthetic data can sometimes give us a resonant feedback on problems we've created for ourselves? How can we explore future designs, generate new designs with outside of this data that we have existing already?
It's funny. I was just watching my team like move shapes around with an LLM this morning and on the geometry as code, and wondering why anyone would want to do that. So I look, I think we're all going to see LLMs be our little companions in our applications of the future, and I think that'll be helpful. Search just seems to, what happened to search? We're replacing search with LLMs and using more resources in the process. So to me, LLMs are kind of the future of search.
Or advertising.
We typically think of a failed CAD deployment as a situation where there's an engineer looking over some draftsperson's shoulder telling them what to do. So the idea of using words in the synthesis of engineering documents has some historical negatives. I think, like, what are we trying to achieve? What's our user story? Mechanical synthesis? I was talking about generative design. Well, sure, talking to your designs might be somewhat useful. Put 1,000 agents on here and analyze all the different loading conditions, possibly. But I don't I don't see something transformational from that technology alone yet. I just think like, and I realize this is anti-trend, but like I think of something like these vision displays that people are wearing. They're not very trendy right now. God only knows if we're going to see more of them. But these things have scanners that are looking at 30 frames a second, are constructing meshes. And that's a very high bandwidth input compared to a mouse or keyboard or, God forbid, text. And so I like to think the things that are going to make a bigger difference in sort of generating, synthesizing design are more going to come from the data acquisition side, maybe in real time. They give us better interaction paradigms. And yeah, well, maybe we'll be talking, but I can't imagine that words are going to do most of the work in engineering. And maybe I'm just too old.
Yeah, I think given the personality type who's very much into engineering, articulated in natural language is probably not the most advanced way for them to communicate. So that may not be the best way for engineering, but it could be for other aspects, and maybe for reporting out to humans who have to then decide whether to give them money or not. Could be where
Maybe
short
comment on this visual interaction, because this is definitely something which the LLM are not good at. I just recently have been at the Dev conference of OpenAI in San Francisco, and there we got the tip to go for Sora models, so like the real like video models. And the idea was, we've not tested it yet, but it was a great idea to actually have a geometry rotated, create a movie, and then actually give this movie to the vision LLM, like Sora, for example, and then ask, okay, what is the surfaces to detect some features, because this seems to be better than text and also better than screenshots, because it's only 2D. So looking for this idea. Not sure if somebody tried it out of this. Blake, Steven, Sheridan, did you try it?
Not yet, but it sounds like a good idea for sure. I think when we've got this capability to be able to change the CAD geometry naturally with some sort of agent, is going to open up many more possibilities. I don't think it needs to be driven with text input, because we can have a multiple agent workflow where the orchestrator agent deals with the engineer in natural language, but then that orchestrator agent talks to the CAD agent through MCP protocol or some other protocol that's going to be developed, a machine-to-machine language. And then that CAD agent is able to drive changes. And what we're seeing, there's a big bottleneck in these processes, because you need to have a parameterized CAD in order to do a design study completely agentically. And if we can remove that step of a human having to parameterize the CAD, it will open up the ability to be able to run many more optimization studies, DOE studies, and much more complex end-to-end workflows.
Yeah, I think an LLM is only able to give input vector, because it's based on speech, and they can discuss everything, but they can't discuss really engineering physical boundaries like we engineers learn in our studies. And so you have to model the knowledge of engineers in parametric models and so on to give agents the possibility to start it. And so yeah, it's the foundation to have this parametric models not only in CAD, in every simulation, to make such a business feasible and possible.
One of my advisees, Mikado, is doing agents that do simulation prep, the defeaturing and mid-servicing and that kind of thing in real systems to do exactly that. I think it's a good use, and a good use of LLMs. That's a great example.
Cool. Ferdinand, can you sort of talk more about how you think the product development process you're seeing from your customers can be automated sort of beyond just parts and into the entire systems?
So first of all, it starts with parts, because as Moritz said, and I really like this quote, it's all about impact. And if you really want to start with an entire system, you will fail because it's too big. And so start with the part, you have the data ready, you have to really gain impact. And then maybe focus on the next part, right, left behind, or something else. And so you start to go from a part to a subsystem to a system and so on. And that's the way to automate a system design. And for that, you need all the interactions between the parts on a geometrical way, on a thermal way, and so on. And that has to be modeled as well to make this system automation possible. But it's always start small and then scale.
I think from some of my experience in the additive manufacturing space, the concept of part consolidation implies that you had a series of parts, which implies you designed it for a previous manufacturing process, and then you're sort of adapting it. When you have a clean slate and you have the ability to design a system, then maybe thinking in parts is something you should do later on down the path. Blake, I know you've been involved in some of these conversations in the past. What have you seen in the adoption of that sort of process of systems first, then coming down and segmenting things down to their manufacturing processes?
I mean, there's two ways of looking at this. There's product development and process development. And typically they get slightly different models to me, taking the product development angle, which is probably a little bit more relevant. I mean, we have this classic kind of this V model where we start with an abstract theory, we break it into subsystems, we come up with requirements for the subsystems, let's go into the further subsystems. And thinking about sort of that differentiable paradigm, this is clearly the right way to do that kind of work. We're doing and there's a lot of 50 years of theory into that kind of setup. On the other hand, the Toyota school of sort of lean product development confronts a lot of that. The top-down process, you have the least informed people making the most assumptions. And so there's an attempt to invert it, to say, hey, the people who are closest to the work know the most about it, and so we start there. I had the opportunity to visit with Evolve Additive a factory, a toner factory in Japan. And it was this 5-story building with cyan, yellow, magenta pipes, kind of like our background here. They showed us this very special place. There was this one little corner of one floor where they had a little area fenced off, and they had some new process, something new that had been invented. And there was an A3, of course, because you always document what you're doing with an A3 outside your office. They explained that this was the first phase of automating up to building a whole new factory. They were inside the old factory. They're going to eventually build a whole new factory, but first they had to figure out how to do it at this work cell scale. And once they did it at the work cell scale, they're going to take it to another scale. And everyone was watching this team of very ordinary people in there doing the work to see everything that they did to figure out how to scale that up. So those are the two answers that I know.
Okay. So in these larger companies, this is a question from anonymous attendee, who's one of our attendees today. Thank you for your question. They're asking if you have any tips on how to bring AI into smaller companies who may not have a lot of data, but may have a lot of traditional views, and maybe it's a family company where there's a lot of like tribal knowledge they're not really willing to share, or how can they adopt these new approaches?
If you don't have any data, start collecting data.
Let's say limited data, but the problem is the culture of a small company with like a family vibe.
So what I have seen at customers who are very in these classical processes, they are looking for external impulses. So they, for example, invite keynote speakers or people to come on site, do a hackathon, for example, to show stuff that it's actually working, which then builds trust. But if from an external view, and then you hope for somebody to pick it up, and but it's not guaranteed, obviously.
Okay.
Maybe you should use out of the box functionalities. So all the huge PLM platforms, for example, as we have seen before, have some functionalities, and don't create your own start with out of the box functionalities, because usually you have a PLM platform. If not, you should start with that, and then start with the already existing tools you have with these platforms.
Yeah, I think our normal response there would be to start collecting data and make sure that you're ready for AI when you have the data. So you don't have to need to implement it today, but so long as you're using tools that at some point can help you to implement AI, then you're preparing yourself for the future, at which point you want to be able to leverage AI.
And on the obviously every situation will be different, but on the basis, what would you think is the most crucial crucial data people should start with, and then how should they build up their pyramid of their data platform? Just started weird.
I'm biased, but obviously it's simulation data.
Yeah, I also would love to say, and it's engineering data, but I think engineering domain is one of the hardest domains to bring AI in. I guess the low-hanging fruits are more on textual data. So whether it's your support ticket system, I guess first level support, these ticket systems, they are so easy to automate. So if you have a support down there, or if you have some emails or something, you want to summarize text in text optimizations, I guess these are really like the low-hanging fruits. But then simulation next.
Simulation and CAD data next, of course. Yeah.
I like 2D drawings. I think that there's a lot of knowledge in drawings that doesn't make it into 3D models like GTOLs. And I'm close with Hinomi. I'm also friendly with the folks at Drafter. They're all doing a very good job taking that very old legacy knowledge and turning into things that you can reuse.
Yeah, I was thinking about 2D drawings recently, actually, like wondering, can we use old technology? I used to be a design engineer, so I'm very familiar with that, to reverse engineer dumb 3D models. So, if you create a topology optimized structure or something, and then you want to create a parametric model in a history-based CAD program, can you do some first angle projections and work out what the 2D drawing would be? And then from that, I think we have much better understanding of how a 2D drawing becomes a history-based 3D CAD model. Interesting ideas.
And there's some work going on in featurizing those kind of parts. G-Nucleus AI is one of the LLM-oriented CAD systems that is creating feature-based models. I think Zoo is doing it as well. I don't have a lot of hope for 3D technologies and BREP-based technologies yet. Yes, for synthesizing parts in certain cases, not so much for modifying them. It seems like it's just because those BREPs and CAD are usually just not very smart. The actual engineering is mostly gone by the time those documents are produced, and it's very hard. Like it's the skill set of designing to tolerance, which you really need to do at the concept stage, is not something a lot of engineers have. So I do think there's a lot of opportunity to take kind of, especially like esoteric knowledge, catalog knowledge. Only let me like make screws that I can buy from McMaster. These kinds of this kind of stuff at your fingertips and just working, I think we'll start to see autocomplete there long before we see it in the bulk form. So rounding things, drafting things, getting the snap fits right. That's where I think we'll see the value initially.
So we've seen a lot of change in the past 5 years. Like, I don't think many of us could have foreseen exactly the agentic systems that have been in place now, like especially that demo by Sonira was pretty impressive. What do you think we will see in 2030 once we've had another 5 years of this development accelerating so quickly? Steve, I'll start with you.
Yeah, so I think we're going to see much broader workflows being possible. So I think we're already seeing that start to happen. The automation of the repetitive, boring tasks. I mentioned earlier, I think the engineers are going to be orchestrating the actual design intent, understanding the complex side of things, understanding the more creative side of the design. I think we're going to be gone of the days where a simulation engineer has to sit for 3 hours and run a mesh convergence study, assign boundary conditions. That all of those things can be automated, and we can run many systems together that take care of those laborious tasks. That's personally where I can see it going.
Ferdinand, 5 years' time?
I completely agree to that, but that means that we have faster product cycles. We don't have, for example, in the automotive industry, 5 years for a new product. It will be 2 years because, yeah, we save this time. We can spend more innovative time. And so the customer will feel it because, yeah, you will have more better, quicker, newer products in the market.
Blake, what are you seeing in 5 years' time?
I mean, there I can only tell you where I'm spending time. But by then, I certainly hope we have an implicit CAD system that's as easy to deploy as Parasolid, so that we can have so that the kind of tools that are working on code, things like Cursor today, can actually do meaningful work on CAD as opposed to working on the scripts. To me, the big focus is getting BREPs out of the way so we can actually be talking in a common language. So that's my big vision. It probably won't work though because of the weight of mainstream CAD and Parasolid. So I don't know what to do about that other than hopefully get better results and cross my fingers.
There's a lot of legacy there. And Maritz, what do you see happening for your customers and Snera in 5 years' time?
5 years is super long. Maybe I'll answer it in maybe 2 years, because what's beyond 2 years, but yeah, what I see a trend at the moment is currently we are using all over the place large language models. So these are really big models, which are kind of universal models. And if you think now of an agent, for example, just like a geometry agent who does the fillets or something, or these kind of, you don't need to have the whole capabilities of the LLM inside your agent AI. So I think we will see a transition towards small language models in the future, super specialized only in one expertise, and maybe even portable on your mobile phone. So you don't need to have like these super high performance GPU hardware sitting around. And then actually things become super interesting, because then this technology will be cheap, commoditized, and really rolled out on a broader scale on your mobile phone. And I'm looking forward to this, to have my Jarvis and my phone with me, and I can talk to, because it's just only specified to the things that I would like to have it.
So you're looking forward to a more fractured AI future?
Yep.
Awesome. And I'm sure we can have the agents talk to each other, bring it together in the end anyway. Awesome. Well, thank you all so much for your time today. Thank you for everyone who joined us. If for more of these presentations, these events, please follow on LinkedIn, Future of Engineering Summit, and we'll be sharing some excerpts from these recordings, and also keeping you up to date of where future ones are. So thank you to the panelists. Thank you to attendees. It's a good pleasure.